quicker than the texture of space-time can stay aware of it, it'll simply tear. I'm alarmed by this. As of now, our evening sky is changing quickly, and in a matter of many years, if not sooner, it may turn out to be totally unrecognizable. Stargazers overall are sounding the alert. Specialists like deGrasse Tyson have as of late confirmed the impending blast of Polaris, and the tale behind it is very terrifying. Polaris, known as the North Star, has for some time been a constant in our night sky, filling in as a pivotal reference point for stargazers, guides, and cosmologists. However, this could soon change, altering our night sky and, furthermore, cosmic estimations. Let's dig into the meaning of this danger and its implications for us all. Join us as we unveil the narrative of Polaris as it approaches its end. For a really long time, Polaris has guided sailors and stargazers alike, standing firm on a respected footing as a guiding light. Its unfaltering presence in the night sky has been fundamental for navigation. Yet, this steadiness may soon be upset. In September 2023, a research paper introduced by the regarded Royal Astronomical Society cast doubt on the destiny of this heavenly light. Polaris is near the very edge of detonating, potentially disappearing from the night sky forever. Before we investigate the results of this discovery, let's learn more about Polaris. Additionally known as the North Star or Pole Star, Polaris is unique because of its proximity to the heavenly North Pole. Positioned straight over Earth's North Pole, it appears practically fixed in the northern sky, found in the constellation Ursa Minor, or the Little Dipper. Polaris shines as a moderately radiant yellow-white supergiant star, much larger and brighter than our Sun. It's not a singular star, but part of a complex triple star system, with Polaris A and Polaris B forming a binary pair, while Polaris B orbits around them. The interactions between these stars create gravitational forces that shape their orbits and affect their behavior. Any disturbances in these interactions can lead to unpredictable variations in the star's brilliance or pulsation patterns. However, the exact mechanisms behind these interactions remain unclear. Polaris is located approximately 323 light-years from Earth, meaning the light we see from it today began its journey quite a while ago. Therefore, if Polaris were to explode now, we wouldn't notice it until more than 3 centuries later. The fact that Polaris has already made this journey makes it possible that it could have detonated, and we're yet to witness the light from that event. Over the course of time, the North Star has held monumental social, navigational, and symbolic significance. Its steadiness and fixed position made it a significant guide for ancient sailors, directing them across oceans and terrains. Symbolically, Polaris has represented consistency and direction, staying resolute in the midst of the ever-changing night sky. For stargazers, Polaris has served as a vital reference point, supporting the study of celestial movements and variable stars. As a Cepheid variable star, its occasional variations in brilliance have provided valuable insights into stellar properties and the nature of variable stars. This characteristic also played an essential role in determining cosmic distances and calibrating instruments. These pulsations follow a predictable pattern, making it easy for us to forecast its behavior. However, recently, Polaris has strayed from this normal behavior. This abnormality in its pulsation cycle has perplexed astronomers, prompting closer examination of this celestial anomaly. Instead of its usual, predictable pattern, Polaris has started showing sporadic periods of dimming, which are now raising concerns among researchers that the star might be approaching the end of its life. This aligns with behaviors typically observed in stars nearing their end, such as the gradual expansion of Polaris' pulsation period, which was once steady. This can be attributed to interactions within its star system. We've noticed an annual increase in the pulsation period of 4.5 seconds, which may seem insignificant, but it holds major implications. Some astronomers propose that gravitational interactions between the Polaris stars could cause these fluctuations in its atmospheric conditions, directly affecting its pulsation patterns. However, others are more alarmed, believing that similarities between Polaris and Betelgeuse suggest the star is on the verge of exploding. The similarities between Polaris behavior and that of Betelgeuse another prominent star in the Orion constellation, are striking. Both stars have exhibited confusing anomalies in their brightness, raising concerns about potential explosions. Stars in their twilight stages often display such abnormalities before reaching the climax of their life cycles. While NASA has expressed heightened concern about Betelgeuse, comparable attention hasn't been officially directed toward Polaris yet. As a Cepheid star approaches the end of its life cycle, it progresses through various stages, including the main sequence stage, red giant stage, and finally, the supernova explosion. Based on Polaris' irregular pulsations, researchers predict it has entered the stages of helium burning, typical of stars nearing their end. These anomalies in Polaris behavior align with patterns indicative of Cepheid stars in their twilight stages. However, conclusive signs of its impending supernova remain uncertain. Stargazers are tirelessly analyzing these anomalies to understand Polaris' destiny. If Polaris were to go supernova, it would likely be a spectacular event in our sky, potentially outshining the moon and becoming one of the brightest objects visible for weeks or even months. Its appearance could dramatically alter our view of familiar constellations, such as the Big Dipper or Ursa Major, of which Polaris is a part. Rest assured, Earth would almost certainly be entirely safe, even if Polaris were to explode, given its mass and distance from us. While a Polaris supernova might not be as visually striking as Betelgeuse, it could still be visible to the naked eye for an extended period, outshining nearby stars. Astronomers and observatories would undoubtedly take notice, sparking interest within the academic community and among stargazers worldwide. However, the specific visibility and impact on Earth's atmosphere or environment would likely be less significant compared to a closer supernova event. But what about Polaris itself? What will be its fate after a potential supernova event? Let's clarify one thing. While massive stars usually end their lives with a supernova explosion, this is unlikely to be the case for Polaris. When a massive star goes supernova, a tremendous explosion occurs within it, marking the final catastrophic stage of its life. This process involves the complete collapse of the core, triggering a shock wave that causes the star to explode violently. However, Polaris isn't large enough to undergo such an explosion. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transformation will not result in a supernova, but rather a peaceful end as it evolves into a small, incredibly dense celestial remnant. A white dwarf is the remnant of a low or medium mass star that has depleted its nuclear fuel. As Polaris sheds its outer layers and transforms into a white dwarf, it will become an incredibly dense, small remnant of its former self. White dwarfs are the final stage for stars like Polaris that lack the mass to trigger a supernova. Over time, the white dwarf will slowly cool and fade, but it will no longer be the bright, shining beacon that once guided sailors and stargazers alike. In the distant future, as Polaris evolves into a white dwarf, it will no longer be part of the vibrant star system that once illuminated the night sky. Its once constant presence will give way to a much dimmer and colder state, eventually disappearing from view. Though this transformation will happen over millions of years, the loss of Polaris brilliance will mark the end of an era in the night sky. For now, astronomers continue to monitor Polaris closely, analyzing its pulsations and behaviors as they try to understand the full extent of its impending transformation. The fate of Polaris is a poignant reminder of the cyclical nature of stars, how they are born, live, and ultimately die, leaving behind remnants that may one day become the foundation for new cosmic events. While the end of Polaris may seem like a far-off event, it raises important questions about the nature of the stars we observe in our night sky. The process of star death is not only fascinating, but it also provides critical insights into the life cycles of stars across the universe. As scientists learn more about stars like Polaris, they gain a deeper understanding of the forces that govern the cosmos and the dynamic nature of the universe itself. For stargazers, the eventual disappearance of Polaris will be a bittersweet moment. It will be the end of a celestial guide that has stood the test of time, a constant in the vastness of space. But it will also serve as a reminder of the impermanence of everything in the universe, even the stars themselves. As we continue to study and explore the cosmos, we will undoubtedly encounter other stars that will one day fill the role of guiding lights, just as Polaris once did. Ultimately, the story of Polaris is not just about a single star. It is a reflection of the broader story of the universe, where even the most steadfast lights will one day fade, giving way to new beginnings. And as we continue our journey through the cosmos, we can only wonder what other mysteries and wonders await us in the vast, ever-changing night sky. Think about a star as huge as the sun, yet compacted to the size of Earth. When this happens, we can never again see its leftovers from our planet, similar to how we notice the star today. Looking at the expected impacts of Polaris explosion, with verifiable cosmic explosion events, gives important understanding into the development of stars and their definitive destinies, contrasting our assumptions and legitimate supernovae like SN 1054 or then again SN 1987A, and later events such as SN 2011 Fe or SN 2014J. These give important information for understanding the likely fallout of Polaris burst. SN 1054, for instance, brought about the arrangement of the Crab Nebula, a nebula that keeps on growing and emitting radiation across different frequencies, offering cosmologists a rich field for study. Also, SN 1987A, seen in the Large Magellanic Cloud, gave bits of insight into the cycles of nucleosynthesis and the elements of cosmic explosion leftovers. Investigating phenomena such as the development of nebulae, the release of enormous beams, and variations in glow can offer insights into Polaris' remarkable attributes. The arrangement of nebulae like the Crab Nebula results from the ejection of material during the cosmic explosion blast, which interacts with surrounding interstellar gas and dust, advancing it with heavy elements and adding to the pattern of heavenly birth and demise. Furthermore, the release of infinite beams and high-energy particles, advanced by cosmic explosion shock waves, has implications for astrophysical cycles and grandiose radiation conditions. To make a definitive examination, researchers assess contrasts in mass, composition, and speed of shot-out materials between Polaris' expected burst and other observed events. This includes considering the light curves, spectra, and remnants from these events, and projecting similar attributes for Polaris' expected burst. Surveying whether Polaris burst could prompt the formation of nebulae or specific natural distributions enhances our understanding of its likely results. Another significant area of examination includes assessing the rotational variability of stars approaching their end stages, much like Polaris, against observed cosmic explosion precursors. This similar examination can help measure similarities or deviations and give insights into the burst mechanism. Pulsational instability in stars approaching the finish of their lives might be indicative of internal insecurities or impending catastrophic events, offering hints to the developmental cycles leading to cosmic explosion blasts. In spite of careful observations and broad analytic examination, astronomers find themselves puzzled by the anomalies seen in Polaris conduct. Unraveling the exceptional conditions driving these abnormalities holds the key to advancing our perception of heavenly development. Understanding the mechanisms responsible for Polaris' sporadic throbs requires interdisciplinary cooperation and the development of cutting-edge theoretical models and observational strategies. The potential loss of Polaris as a crucial reference point in the night sky presents significant concerns for cosmic endeavors. Ground-based telescopes and divine measurements would require recalibration, affecting the accuracy of cosmic estimates. The shortfall of Polaris could also influence navigation systems and cultural practices based on heavenly milestones, highlighting the importance of this celestial event. The cryptic behavior displayed by Polaris emphasizes the significance of monitoring heavenly phenomena and fostering collaboration to address questions surrounding star development. Polaris' future remains questionable, but it serves as a powerful sign of the ever-changing nature of our universe. While its eventual fate remains cloaked in mystery, the study of stars like Polaris extends our understanding of the universe and its immense, unusual nature. Whether we witness Polaris' emotional end, its heritage as the North Star will undoubtedly leave an enduring imprint on humanity's history and our exploration of the stars. As scientists continue to monitor Polaris, they are also developing new techniques and methods to predict and understand the behaviors of stars approaching the end of their life cycles. The ultimate goal is to gain a better understanding of heavenly development and the various paths stars can take as they age, including refining our ability to predict when such enormous events as supernovae could happen. The study of Polaris inconsistencies adds a vital piece to the riddle, offering new insights into how stars act as they move toward their final stages. In the broader context of our solar system, the destiny of Polaris has implications for how we view the universe as a whole. The stars that light up the night sky are far more transient than many of us realize. While Polaris might appear to be a steady signal to us, in reality, it's only one of countless stars, each on its own journey. The inevitable change of Polaris, whether it fades quietly into a white dwarf or detonates dramatically, mirrors the life cycle of many other stars across the universe. In a way, the story of Polaris reflects our own curiosity and quest for knowledge. As we look up at the night sky, we often seek consistency, something to anchor us in an otherwise chaotic world. Yet the universe is far more powerful than we can ever fully grasp. Stars like Polaris remind us that everything, even the most stable parts of our sky, is continually changing, evolving, and ultimately fading. For now, as astronomers continue to gather data and refine their models, we may need to wait to witness the end of Polaris. It could be years or even centuries before the true nature of the star's death is revealed. But rest assured, the academic community will be watching closely. Whether as a quiet fading or a magnificent explosion, Polaris will leave a lasting mark on our understanding of the universe and the forces that govern it. While we may never live to see the final moments of the North Star, the legacy of Polaris will surely continue to inspire generations of scientists, astronomers, and visionaries. Whether it grows dim or erupts in a brilliant burst of light, Polaris has already secured its place in the history of stargazing. It has been a guide for countless travelers, a marker of time for ancient civilizations, and a symbol of permanence in an ever-changing sky. The fate of Polaris may be uncertain, but its role in our story is undeniable. As we look to the stars, pondering the mysteries that still remain, we can hardly comprehend what revelations await us next. The universe, however vast and mysterious it may seem, will continue to unfold its secrets, one star at a time. The unfolding of cosmic secrets, one star at a time, will be a constant journey for astronomers and astrophysicists. With each discovery, we move closer to understanding the intricate processes that govern the life cycles of stars, their births, and their inevitable deaths. The study of stars like Polaris, with its distinctive behavior, adds a critical layer to our knowledge, revealing the dynamic forces at play in the cosmos. As technology continues to advance, so too will our capacity to observe and analyze the distant stars and phenomena that have, until now, remained beyond our reach. New instruments, more powerful telescopes, and innovative techniques will provide us with increasingly precise data, allowing us to witness the end of stars like Polaris and explore the ultimate fate of such celestial bodies. The implications of these discoveries will extend beyond our understanding of the stars themselves. By studying Polaris and similar stars, we gain insights into the larger workings of the universe, including the role of stars in the creation of elements, the formation of galaxies, and the complex interactions between cosmic structures. Each observation brings us one step closer to unraveling the mysteries of our universe. In the future, the demise of Polaris, whether through a quiet transformation into a white dwarf or a dramatic supernova explosion, will likely provide a wealth of information that deepens our understanding of stellar evolution. It will serve as a key event in the broader narrative of our universe's development, allowing future generations of scientists to build upon the discoveries of today. Polaris, in its quiet majesty, continues to be a beacon for those who look to the heavens for answers. Its eventual fate, whatever it may be, will remain a profound reminder of the ever-changing nature of the universe and our ongoing quest to understand it. As we gaze up at the night sky, the North Star will always hold a special place in our hearts, not just as a constant guide, but as a symbol of our unending curiosity and our relentless pursuit of knowledge.